2022 October November paper 22. So let's take a look at the first questions. Find the set of values of K for which the systems of equations given here has a unique solutions. So in order to have a unique solutions, the determinant will not be equal to 0. So the determinant will be the coefficients of the x, y, and z. So we just write down the coefficients. So we just need to find the determinant. So it will be 36 minus the 48 minus the 2 of the 9k minus the 42 plus the 3 8k minus 28 not equal to 0. Okay, so just simplify, expand, simplify, then you will get this one as a 6k minus 12 not equal to 0. Your k is not equals to 2. Okay, done. So this will be the set of value for which of the systems of equations that has a unique solutions. Okay, so now we move on to the question number 1b. Interpret the situation geometrically in the case where the systems of equation does not have a unique solution. So if it does not have a unique solution, that means your determinant must be 0. If your determinant 0, that means your k must be equal to 2. Okay, so when your k is equal to 2, your systems of equation will look like this. Let me just copy down the systems of equations. So we have a kx, the k has become 2. So it's a 7x plus 8y plus 9z equal to 3. So you can observe that these two equations actually are quite similar. So what you can do over here is that you just take these equations. I call this one equation 1. And this one, I just divide everyone by 2. Then I call this one equation 2. Okay, so the third equation is not so relevant. The third equation is not so relevant to us. But however, you can see that the equation 1, plane number 1 and plane number 2, they are having the same coefficient, which means that they're having a same normal vector. Okay, that means they these two planes are parallel, but because this one is not the same. Okay, so you can say that interpret the situation geometrically. They not require us to solve it. They're asking us to interpret the situation geometrically. So we just say that the plane 1, plane 2, parallel. But for parallel, we need to highlight again that they are not identical. We need to highlight this is because parallel, it could be this is parallel. This is the case. Okay, but parallel also can be these two planes, they overlap. Okay, these two planes, they overlap. So if these two planes overlap, they also will share the same normal vector. So it's important to highlight that they are parallel but not identical. Okay, so the plane number 3, maybe we call this one number 3. Then plane number 3 is not parallel. To plane 1 and 2. Okay, so this will be the descriptions. However, the drawing will be like this. So it will be something like this. Two planes are parallel. Then you have another plane number 3, which is not parallel to them, something like that. So for this case, they will not have any solutions. No, the unique, this, how to say, they do not have unique solutions. Okay, yeah. So move on. Question number 2. 3. The curve has equations of x plus 1 multiplied by y plus y squared equal to 2. Show that the dy dx equal to negative 2 over 3 at the point of 0, negative 2. So what you need to do is to do the implicit differentiations. So this is the equation that they give you. Just keep the left, differentiate the right, plus keep the right, differentiate the left, then the 2y, implicit differentiations, you get this. So at the point 0, negative 2, okay, we need to simplify first. So we will have x plus 1 plus 2y dy dx is equal to the negative y. So your dy dx is a negative y over the x plus 2y plus 1. At the point 0, negative 2, your dy dx will be negative 2 here, 0, negative 4 plus 1. So at the end, you get negative 2 over 3. Shown. So this will be the answer for the part A. Move on. We want to find the d square y ds square. So the second order differentiations over here. Second order differentiations, we will differentiate from here. That will be better. Usually, I will not go into differentiate from here. It will be more troublesome. So I prefer to differentiate from here. So I just copy down this result, x plus 1 plus 2y dy dx. Equal to the negative y. So I differentiate it, keep the left, differentiate the right. Plus keep the right, differentiate the left. The right hand side over here, you differentiate it. Okay, so you can simplify them. It will be plus dy dx plus the 2 of dy dx square equal to the minus negative dy dx. So your d square y dx square is actually equals to, not so rush. It's better be careful. So here is negative 2 dy dx minus the 2 dy dx square. So the dy dx is these expressions, but I don't plan to substitute this expression inside here. I think it will be quite troublesome. So over here, I just write this as the d square y ds square as the negative 2 dy dx 1 plus dy dx divided by x plus 1 plus 2y. I write like this. So when at, not to say when, at the point is 0, negative 2. So my d square y ds square is equal to the negative 2. Just now from part A, your dy dx is negative 2 over 3. So this one will be 0 plus 1 minus 4. So if you do it carefully, 1 over 3, 4 over 24 over 27. Negative. Yeah, correct. Okay. So this will be the answer for the number 2. So move on. We have question number 3. A curve has the equations like this. For the x between 0 to 1 inclusive, find in terms of pi and e the area of the surface generated when the curve is rotated 2 pi radian about the x-axis. Okay, so we know the formula of the surface area generated. It will be like this. This is the formula. But we will not begin with this one first. I will begin with this expression first. Okay. So to begin with these expressions, you will need to find the dy dx first. So the dy dx, you will have e power x minus 1 over 4 e power negative x. Then we do this. So it will be 1 plus the e power x minus the 1 over 4 e power negative x squared. So if you expand them, you get 1 plus e power 2x minus the half e power, half only. Okay, then this one, it will be 1 over 16 e power negative 2x. So if you simplify it, you will get this. Okay, so you can see that over here we can factorize it. If you factorize it, you will get e power x plus 1 over 4 e power negative x square, and you will get e power x plus 1 over 4 e power negative x. Okay, so we just show this. Now your surface area S is equal to integrate 2 pi from 0 to 1 y square root over 1 plus the dy dx. We write down the formula first. Then just replace the y. Convert the y to become e power x minus 1 over 4 e power negative x. This one will be e power x plus 1 over 4 e power negative x dx. Okay, so you will expand them. Sorry, this is a plus. So if you expand them, you will get e power 2x plus the half plus the 1 over 16 e power negative 2x dx. So not difficult, just direct integrate, provided you need to be very familiarized with the integration formula. So just replace the value, then you were done. Yeah, you were done. Okay, so over here, just replace e power 2 plus 1 minus the 1 over 32 e power negative 2 minus the half plus 0 minus 1 over 32. Okay, so just expand, simplify. We just want to leave the answer in terms of pi and e. So you will get this one as the e square. This one is this cancel. No more e, no more half. So it will be plus 16. Plus 16 is a constant. I put it back at the behind. But it doesn't matter. Actually, we just follow the sequence. You just put a 1 over 16 here. Then at the end, this one, it will be negative 1 over 16 e power negative 2. Okay, so you can leave the answer like that, no problem. But of course, you can also make it become e square minus the 1 over 16 e square plus 1 over 16. That is up to you. So I think until here is good enough. Okay, so to me, until here is good enough. Okay, so that will be the answer for the question number 3A. Move on. We have 3B. Now they want you to use the standard result from the list of the formula MF19 or otherwise find the Maclaurin series of this. So this one 2 marks only. So from here, we just say that from MF19, we have the formula for exponential function ex, e power x, it will be 1 plus x plus the x square over 2 plus a dot, okay, because this one is until x square. So we just show until x square. Then similarly, e power negative x will be 1 plus the negative x plus the negative x square, 2. 1 minus x plus the x square over 2. So the e power x plus 1 over 4 of e power negative x, it will be 1 plus x square over 2 plus the 1 over 4 of 1 minus x plus x square over 2. And then plus a dot. Expand simplify, then your answer will be 5 over 4. Just use your calculator. Done. So this will be the answer for the question number 3B. Moving on, we have question number 4. Find the solutions of the differential equations given here, which the x equal to 3 when t equal to 1, giving your answer in the form of x equal to the function of t. So what you need to do is to identify how to solve it. So over here, you can see that it's a linear equations. We can use the IF, integrating factor, to solve it. So first of all, I need to divide everyone by 4t squared minus 1. So you get this. T squared minus 1 divided 4t squared minus 1 is a 1. So now your IF is actually you need to integrate e to the power of e to the power of integrate this function. Okay, so this one will be a bit troublesome. Actually, you can use the formula booklet ML19 to look for the formula to solve it. But over here, I will show you. This one can be solved by using the partial fractions. So you factorize 4t squared minus 1 to become 2t plus 1 and 2t minus 1. So you will get that this the d is a half. You get the b as a 2. When the d is a negative half, you will get your a is a negative 2. So that means these integrations can be written as I put b in the front. B in the front is a 2 over the 2t minus 1 minus a 2 over 2t plus 1. Then when you integrate it, it will be ln of 2t minus 1. Actually, no need to put modulus. That's the ln of 2t plus 1, the whole thing, power. So it will be e power ln of 2t minus 1 and 2t plus 1. So we know the one of the properties of e power ln. E power ln, it will be the function inside the ln itself. So this will be your IF. So once you have the IF, you just multiply everyone by the IF. Maybe I call this one equation 1. So take the equation 1, multiply by the IF, then you will get this. One 40 square 2t minus 1 over the 2t plus 1 multiplied by 4 or 40 square minus 1 x equal to the 2t minus 1 and 2t plus 1. So we need to simplify it first. But we need to simplify it first. So if we simplify it, you will get this as the 4 over 2t plus 1 square. Now your left hand side is actually similar to the differentiations of 2t minus 1, 2t plus 1 multiplied by x is equal to this. Then you just need to integrate both sides. That means integrate both sides. Then you will get integrate d of this is equals to integrate 2t minus 1 2t plus 1 dt. So your left hand side is the result will be straight away like this. This is your left hand side result. Your right hand side result, it will be it's an improper fractions actually. We make it become proper by 1 minus 2. This one you can use long division or any way to split them, become reduce them to become proper fractions. Okay, so in integrate this, you get negative 2 minus the ln of 2t plus 1 plus a c. So your x, okay, we need to find the c because the question giving you t equal to 1, x is equal to 3. So when t equal to 1, x is equal to 3. So it will be, if you put 1 inside, you will get 1 over 3. 3 is equal to 1 minus the ln 3 plus c. So that means your c is a ln 3. C is a ln 3, correct? Okay, we need more space. So after you found the c, just replace the c back. It will be like this. Equals to the t minus the ln of 2t plus 1 plus the ln 3. So we just join everything together. So you get x equals to the 2t plus 1, 2t divided by 2t minus 1. So we just put a big bracket here. You combine everything together, it will be ln of 3 divided by 2t plus 1. So we can just leave it like that. There's no need for you to expand them. Okay, there's no need for you to expand them. Yeah, okay. So we can just leave the answer like this. That's all. Okay, done. So this is the answer for the question number 4. So now we move on to question number 5. Roots of unity. So the fourth roots of unity is actually means that the z to the power of 4 is equal to 1. So we know that the 1 is actually cos 0 plus I sine 0. Actually, no need. This one wasting time. We no need to make it so become a complex number because simple algebra factorizations will do. Make it like this. We know it's a z squared plus 1, z squared minus 1. Then z squared is a negative 1, z squared is a 1. So we have the z, it will be plus minus I, and your z will be plus minus 1. Done. So this will be these are the 4 roots of the unity. So therefore, z is equals to the 1, negative 1, I, and negative I. So this will be the answer for part A. Done. Then I move on to the part B. We have a de Moivre theorem. So I use the de Moivre theorem show that the cos 4 theta equals to the 8 cos power 4 minus 8 cos square plus 1. So over here, we will just let the cos theta plus I sine theta as a short form of C plus IS. So the cos theta plus I sine theta, we want power 4. So we have a C plus IS also power 4. By using the Moivre theorem, your left-hand side, by using the de Moivre's theorem, so I get cos 4 theta plus I sine 4 theta for the left-hand side. Your right-hand side is a binomial expansion, C power 4 plus 4C cubed IS plus the 6C squared. 4C2 is a 6, so 6C squared IS power 2, and plus the 4CIS power 3, and IS to the power of 4. So you have a cos 4 theta plus I sine 4 theta. It will be C power 4 minus the 6C squared S squared plus the S power 4 plus the I of the 4C cube S minus the 4C S cube. So this will be the expressions. So we are looking for cos 4 theta. So we only compare the real and the real. So we compare the real part. So you have a cos 4 theta is equal to C power 4 minus a 6C squared S squared plus S power 4. Okay, so we know that C squared plus S squared is equal to 1 because C is representing cos, S is representing sine. So we are having S squared is equal to 1 minus C squared. Okay, so we are having these expressions. Highlight these expressions. So this one can be written as this. So expand C power 4 minus a 6C squared plus 6 power 4, 6C power 4 minus plus a 6C power 4 minus 2C squared plus 1. So total you have xc power 4 minus a xc squared plus a 1. So your C, change it back to cos. Therefore, cos 4 theta is equals to the 8 cos power 4 theta minus a 8 cos square theta plus 1 shown. So this will be the answer for the number 5B. Move on. 5C, you'll be having the polynomial equations like this. Then we will going to find the answer in a cos q pi, where q is a rational number. Q is a rational number. Okay. So first of all, we make this become 8x power 4 minus the 8x squared plus 1 power 4 is equal to the 9 over 16. Okay. And we let our x is equal to the cos theta. So you will get 8 cos power 4 theta minus 8 cos square theta plus 1 to the power of 4 is equal to 9 over 16. So that means this one is a cos 4 theta to the power of 4 is equal to the 9 over 16. Okay, so your cos 4 theta is something similar to the z square equal to the 1 just now, right? Okay, if you want to make it equal to 1, you can just, how to say? Actually, no need. We don't need to make it become equal to 1. So we will be having this one as the plus minus of the fourth root of 9 over 16. We will ignore the complex number part, okay, because we only want the real value part. Okay, so we just consider these two only. So we will have cos 4 theta is equals to the Z3 over 2. And cos 4 theta is equal to the negative Z3 over 2. We only have these two answers. The rest is complex number. So for cos 4 theta equal to the Z3 over 2, we need to refer to the general formula. General formula, it will be cos 4 theta, cos 4 theta. How do you get Z3 over 2? The smallest positive value that give you the Z3 over 2 is pi over 6. This one, the smallest value that give you, positive value that give you Z3 over 2 is a cos of 5 pi over 6. So just refer to the general formula. You get the 4 theta is equal to the 2n pi plus minus of pi over 6. This one, you will get this one as a 2n pi plus minus 5 pi over 6. Okay, so your n is equal to the 0, 1, 2, and 3, and so on. This one, your n is also 0, 1, 2, and 3, and so on. So if you replace 0 inside, okay, yeah, so you can see that your 4 theta, if you put 0 inside, you will get pi over 6. If you put 0, you can get negative pi over 6. This one, it will give you, if you put 2 inside, 2, 4. If you put 2, sorry, if you put 1 inside, 2 pi, 12, 13, 11, okay. Then this one is actually we do not want negative. If we don't want to be negative, then it will be 2 pi. Pi minus pi over 6. So it's a similar. This one is the same. Pi will be here. 2 pi minus pi over 6. 2 pi. 2 pi is a 12, 11. So this one is the same. This one is the same. These two are same. So same, that means we do not need to use this. We use this will do. Okay. So you had to check carefully. So it will be 11 pi over 6 and 13 pi over 6. This is the case where n equal to 1, n equal to 0. This is the case where n is equal to 1. Now the n is equal to 2. So for n equal to 2, if you put inside, you will get this as the 25 pi over 6. Another case will be the 23 pi over 6. So we do not want this one because this one is already more than 2 pi. This one is already more, how to say, this one is too much already. Actually, it's over because we want the smallest value possible. So this one is a 23 pi over 6. So the 25 pi over 6 is already over. So we do not want it to be over. What do I mean by over? What do I mean by over? So you can see that if you divide by 4, you can see that it's over. This one, it will be 25 pi over 24. So it's already more than pi. It's already more than pi. So it's already more than pi. So we do not want it to be more than pi. Maybe we want to be within. So this one, we just show the value until here. 4 values over here. So similarly, this one also similarly, the same thing happened over here. You just do the same thing. So you will get the 4 theta will be equal to the 5 pi over 6. So need more space. 4 theta over here will be 5 pi over 6. Similarly, just repeat whatever we have discussed over here just now. So this one, it will be 17 pi over 6. 7 pi over 24. 7 pi over 6. $70 pi over 6 and 19 pi over 6. So this one, the data will be 5 pi over 24, 7 pi over 24, 17 pi over 24, and 19 pi over 24. Okay. Let me write down here. Okay, so this will be the answer. So total together we have 8 answer. Total together we have 8 answer. 4 answer here, 4 answer here. So total we have 8 answer, which is matched with the expressions over here, because this one is the you have 4 answer here. You have 4 answer here. But some of you may ask, isn't it power 16? You're supposed to have 16 answer. Okay. So this is the power 4. This is the power 4. So it's actually x power 16. X power 16, we're supposed to have 16 solutions. But we only have half of it. How come? Because they are looking for real root. So the real root, 8 of them. So the cos 4 theta have, your cos 4 theta will have positive sub-3 over 2, negative sub-3 over 2. Another one is a positive sub-3 over 2i. And another one is a negative sub-3 over 2i. So these two will give you real number. And these two will give you complex number. Okay, so we do not want complex number because the question asking for real root. So we only have these two. We only need to solve these two only. Okay, so that is the reason why we only have 8 answer. We don't have 16 answer because we only have 8 real roots, and another 8 of them, they are complex root. So we will, this will be the answer for this questions number 5. And now we move on to the question number 6. Question number 6. The diagram shows a curve for the x greater than 0 together with a set of n-1 rectangles with a unit width. By considering the sum of this area, show the of this rectangle, show that this relationship is true. Okay, so what you need to do over here is to let this as a function fx. Okay, then you just show the rectangle. You want this area of rectangle less than the integrations. So when you see the series over here means it's area of rectangle, sum up the area of rectangle. So in order for the area of rectangle to be lower than the graph, then you need to choose this as your F2. Start from F2 and then N at Fn. So you just start from F2 multiply 1 plus the F3 multiply 1 plus until the Fn multiply 1. It will be less than the integrations of 1 until n, the function itself. So now your left-hand side can be written as this. Your right-hand side, you need to figure out how to integrate them. Over here, you can use completing the square. Okay, so over here, I plus the F1. This one, I also plus F1. Now to integrate this one, just use the formula booklet MF19. Just refer to the formula MF19. You can get this one as the arc cos of x plus 1 from 1 until n. Okay, so this one erase. So now your left-hand side can become this already. And F1 is a 1 over square root of 1 square plus 2. Okay. So this one, your right-hand side will be the cos of n plus 1 minus the cos of 2. Okay. So your left-hand side will be written as 1 over square root of r square plus 2r. 1 over 3. Now this one is the inverse of cos. But the expression that they give you over here is in the form of ln. So we know that the cos, the formula, also formula booklet MF19, look for the logarithm expressions for the inverse of hyperbolic functions. So it will be ln n plus 1 plus the square root of n plus 1 square minus 1 minus the ln of 3 plus the square root of ln of 2 square root 3. Formula just for your information. Cos of x is equal to the ln x plus the square root of x squared minus 1. This is the formula. You can find this formula in the formula booklet. Okay, so now simplify it. We still have one more step. Complete the whole thing. So you will get this one as a ln of the n plus 1 plus the square root of n squared plus 2n. Minus a ln of 2 plus a 3. I don't plan to combine them because actually the expression shown, they didn't require you to combine them together. So is it the same? Yes, exactly the same. Okay, shown. So done. Okay, so this will be the answer for the question number 6. Move on. We have question number 7. Square matrix. Okay, with the with corresponding eigenvector A. So non-singular means the determinant is not equal to 0. So we have an eigenvector E. Show that the lambda power -1 is an eigenvalue of A inverse for the E, which E is corresponding to the eigenvector. Okay. So what you need to do here is that we just start from here. So this one, nothing wrong because we already know that E is eigenvector with the corresponding value of lambda. Okay, so this one will fulfill. Given, this one is given. So nothing to argue. So what you need to do is you need to show this. You need to show that this is equal to this. We want to show this. So how to show this? So we just need to multiply inverse A inverse for both sides. So we need to follow the rules correctly. So A inverse and A will give you I. So this one you can actually make it like this. Okay. So you will get this. So you will get lambda AE is equal to the E. Like this. Okay, this is the I. I means identity. So, and then after that, you multiply lambda power -1. Just now over here, multiply A inverse. So you will get this is equal to this. Shown. Okay, so this is how you show it. That's all. So this is the answer for 7A. Now we move on to the 7B. Given that the -1 is an eigenvalue, so we want to find the eigenvector. So we are having the determinant of the A minus a lambda I. So it will be look like this. It will look 2 minus lambda. Actually, we do not need to find the determinant. We only make it like this. Matrix only. Matrix only. So it will be 15, 3, this matrix, 0, -4, 0. So it's a 0, -4 minus lambda 0, and the 3, 3, 2 minus lambda. Okay, so this is what we have. Then when the lambda is a -1, then this one it will be 3, 3, okay. So you can see that to find the eigenvector, we just take the first 2 rows. Just take the first 2 rows we'll do. Or the second and the third row. Okay, but these two are same. Okay, the first row and the third row are same. You cannot choose the first and the third row. You only can choose the first and the second, or the second and the third. Okay, to find the eigen vector. So this one, just do the cross product. You will get 9i plus the 36j minus the 9k. Factorize the 9 out, you get 1 for -1. So therefore your eigenvector is 1, 4, negative 1. Okay, that is your eigenvector. Okay, done. Then now move on to the C. They're giving you these are the eigenvector. And then find the eigenvalues. So just take the matrix A, multiply with this eigenvector, and we see what the result is. So the matrix A is a 2, 15, 3, 0, negative 4, 0, and 3, 3, 2. So just expand, just multiply the two matrices together. Over here, you will get 0, negative 4, 0. Factorize a negative 4 out to make this same as this one. So therefore, this is your eigen value number 2. This is your eigenvalue number 2. Same thing. Similarly, you do the same thing for the third vector here. 2, 15, 3, 0, negative 4, 0, 3, 3, 2. Okay, just repeat the same process. Then you can see that you get 5, 10, 5. Factorize the 5 out. You get to 1, 2, 1. So over here, this will be your eigenvalue. Okay, so by the way, this is the E2. This is the E3. Then this is the E1. That means this will be the lambda 1. Okay, so we have all the lambda 1, lambda 2, lambda 3 already. This is the part C done already. Now we go for the part D. Part D, we want to find the matrix P. So the matrix P is actually all the three eigenvector, E1, E2, and E3. In any order, in any order. So this will be just now the E1 is the a 1, 4, negative 1. Then the E2 is a 0, 1, 0. Then the E3 is a 1, 2, 1. Just like that. No need to explain anything. Just write down the P like this. Then your diagonal vector will be lambda 1, lambda 2, lambda 3. Diagonal matrix, lambda 1, lambda 2. Lambda 2 just now is negative 4 and 5. Negative 4 and 5. This is the diagonal matrix. Okay, this is the diagonal matrix. But the A inverse is equals to the B of the diagonal matrix that you have here, power negative 1. The power here and the power here must be the same. Okay. So that means your D is equals to this. Power negative 1. So it will be power negative 1. Just treat it as a power negative 1. It will be the reciprocal. So done. This will be the answer for the part D. And we move on. We have the part E. Use the characteristic equations of A to show this result. And the P and Q is the rational number to be determined. Okay. So we need to find the characteristic equations. Characteristic equation, just take your lambda 1, lambda 2 as the root. Your lambda 1, lambda 2 as a root. Your lambda 1 is a negative 1. Your lambda 2 is a negative 4. Your lambda 3 is 5. Multiply all together, you get 0. So expand them. If you expand them carefully, so over here, I just direct expand to you. Then you get this. So according to Cayley-Hamilton theorem, says that the A cube minus a 21A minus a 20I will equal to 0 vector, a 0 matrix. So you will be having the 20i is equals to the a cube minus the 21a. Multiply everyone by a inverse. You get 20a inverse is equal to the a square minus the 21i. So your a inverse will be 1 over 21, 1 over 20a square minus a 21 over 20i. So therefore, your p is a 1 over 20 and your q is negative 21 over 20. So this will be the answer for the question number 7. Done. Move on. We have question number 8. The cost you and it fulfill this condition. Okay, show that the d square y dx square plus dy dx minus 2y is equal to e power negative 4x. Okay, so what you need to do is you start from here, y. So your dy du, but I need to find dy dx. So I will find dy dx. Since it's like that, I need to use implicit differentiations. dy dx means you differentiate this with respect to x. It will give you sine u du dx. Okay, so start from here. We want to find the second order. To find the second order, d square y dx square. That means you differentiate this. Again, you differentiate this again. So you will get implicit differentiations. So you have a cos u, keep the left, differentiate the right, sorry. Keep the left, differentiate the right, plus keep the right, differentiate the left. So it will be cos u du dx square. Okay, so this is what we have. Okay. So how to convert? So from here, you need to understand that square root of cos square u minus 1 d square u dx square plus the du dx plus the cos u du dx square minus the 2 cos u is equals to the 4e power negative x. So do you see that we have this one similar? Okay, but however, first thing you need to know that this one is psi square u square root. So this one we can straight away just direct change it to become sine u1. Okay, like this. So first of all, we simplify the first part. The rest, just be patient. No need to copy down. Just copy down only. No need to modify anything. So once you expand, you will get this one as a sine u d square u dx square plus the cos u du dx square plus the sine u du dx minus the 2 cos u equal to the 4e power negative x. So do you see this? And this are the same. So that means this part, we combine them together. Then this part, after you expand, it will be this. So from here, we will just say that, straight away say that just put it like this, just put a bracket. So this one, it will be same as the d square y dx square plus the dy dx minus the 2y is equal to the 4e power negative x shown. Okay, so this is how you show the result. That means you can solve these equations if you want to solve. That means solving these equations is the same as solving these equations. Okay, so now we move on to the part B. Find u in terms of x. It's given that when x equal to 0, u equal to ln 3, and du dx equal to the 3. Okay, so from here, you get your d square y ds square plus the dy dx minus the 2y is equal to the 4e power 1. Oops, sorry, is equals to the 4e power negative x. So we use the AE, auxiliary equations, for the left-hand side. Then you factorize it, m plus 2, m minus 1 equal to 0. Your m is equal to the negative 2, and your m is equal to 1. Then your contemporary solutions will be y equals to the ae power negative 2x plus the be power x. That is your contemporary solutions. Now we go for the yp. Okay, so we just let our yp. Your right hand side is an exponential function, so this one will be be power negative x. So you find your yp prime, yp double prime. Okay, so replace them inside, you get the yp double prime plus yp prime minus a 2yp is equal to 4e power negative x. So it will be be power negative x plus the negative be power negative x minus the 2e, 2b. So this one all joined together, you will get negative 2p. Oops. This one is the b e power negative x. So you get the b as a negative 2. So your particular integrals will be the negative 2e power negative 2 negative x. Your y is equal to the yc plus yp. That will be equal to the ae power negative 2x plus the be power x minus the 2e power negative x. Yeah. Okay. So this will be your general solutions, but we want particular solutions. Okay, so for the particular solutions, we need to find the dy dx. It will be negative 2ae power negative 2x plus the be power x plus the 2e power negative 2x. So given when x equal to 0, your u is equal to ln 3. U equal to ln 3 means u is a ln 3. So your y is a cos u. Y is a cos ln 3. Cos ln 3, you can press a calculator. So cos ln 3, you press your calculator, you get 5 over 3. So you will get from these equations. So your 5 over 3 will be equals to the ae power 0 plus the be power 0 minus the 2e power 0. So you will get a plus b is equals to the 11 over 3. That is your first equations. then when the x is equal to 0, your du dx is a 3. Du dx is a 3. What is your du dx? This is your du dx. So your dy dx is equal to the psi ln 3 dy dx. Press the calculator again. Then you will get this one as a 4. So we just need to use these equations. You will get 4 equal to the negative 2a plus the b plus the 2. That will give you negative 2a plus b is a 2. That will be your equation number 2. Just take the equation 1 minus the equation 2. You will get 3a is equals to the 5 over 3. That will give you a is a 5 over 9. Then from the equations 1, you get your b is 11 over 3 minus the a. So you get 33 minus 5, 28 over 9. So therefore, your answer will be the y is equals to the a e power negative 2x plus the b e power x minus the 2e power negative x. Okay. But haven't finished yet because this is the y. Our y is a cos u. Our y is a cos u. Change your y back to cos u, but we want y u in terms of x side, right? So it will be a cos of the whole thing here, and then we are done. Okay, so done finally. This will be the answer for this questions number 8. And this will be the last answer, last question for this paper. So I'll stop the video here. I'll see you next time. Bye-bye.